The universe is lazy, not figuratively, not metaphorically, literally lazy. Every single thing that happens in the cosmos, from a ball you throw to the light bouncing off this screen, follows one rule: do the minimum work necessary. This is called the principle of least action. And once you understand it, physics stops looking like a collection of random laws and starts looking like a conspiracy, as if the universe is optimizing itself. Let me show you how deep this goes. Throw a ball, watch it arc through the air, parabola, beautiful curve. Now ask yourself, why that curve? You learned in school that gravity pulls it down, fair enough. But here's the disturbing question. Out of infinite possible paths the ball could take, why does it choose that specific parabola? You might say it doesn't choose. It's just obeying Newton's laws. But here's what Feynman showed in his lectures. Newton's laws and the principle of least action are two ways of describing the same thing, and the least action version reveals something unsettling. The ball acts as if it calculated every possible path from your hand to the ground, measured the action of each path, and picked the one with the minimum value, as if the ball did homework before moving. In the Feynman Lectures on Physics, Feynman explored this principle extensively. He showed that you can derive all of classical mechanics, Newton's laws, conservation of energy, everything, from one simple statement: nature minimizes action. But what is action? This is where it gets technical for a moment, but stay with me. Action is a quantity you calculate by taking the difference between kinetic energy and potential energy at every moment along a path, then adding it all up. Think of it like a score. Every possible path gets a score, and nature picks the path with the lowest score. But here's the really strange part. To know which path has the lowest action, you'd need to know the entire path from start to finish before you begin. You'd need to see the future. So how does a dumb ball with no brain, no foresight, no planning ability know which path minimizes action? It doesn't. And that's the key. When Feynman developed his path integral formulation, he revealed the secret. The particle doesn't choose one path. It takes every path simultaneously. But most paths cancel each other out through quantum interference, and the path that survives, the path you actually observe, is the one where action is minimized. The ball isn't optimizing, the universe is, by trying everything and keeping what works. Let's make this concrete with light. You're standing in a room, light from a lamp bounces off a mirror and hits your eye. Why does the light take the path it takes? In the 1600s, Pierre de Fermat figured it out. Light takes the path that requires the least time, not the shortest distance, the least time. This is called Fermat's principle, and it predicts everything: why light reflects at equal angles, why light bends when entering water, why lenses focus. But again, how does light know which path is fastest? Imagine you're at the beach. You see someone drowning in the water. You need to reach them. Do you run straight toward them? No, you run along the beach where you're fast, then enter the water at an angle, because you're slower in water. The quickest path isn't a straight line. Light does the same thing. When it moves from air into water, it bends. Not because something pushes it, because the bent path is faster than the straight path. But the photon doesn't have a map. It doesn't calculate. So what's happening? Feynman's answer in QED: the photon tries every path, every angle, every bounce, every crazy zigzag, and the paths near the minimum time path constructively interfere. The others cancel out. You see one path, but the photon explored infinity. Now here's where your brain should start hurting. If a particle explores all paths to find the minimum action path, then it has to try paths that go into the future, loop back, or take 10 years to reach a destination 1 meter away. Does that mean the particle knows the future? Does it mean causality is broken? No, it means your intuition about causality is too simple. In The Character of Physical Law, Feynman addressed this directly. He said the principle of least action isn't about particles making decisions. It's about mathematics. The equations that describe nature happen to have a form where you can calculate outcomes by minimizing a quantity called action. It's not that the universe is lazy, it's that the math of physics has optimization built into its structure. Think of it like this. You have a rubber sheet stretched between 2 points. You press down in the middle. The sheet forms a curve, a catenary. Why that curve? Because it's the shape that minimizes potential energy given the constraints. The sheet isn't thinking. It's just responding to tension, and tension, mathematically, acts like an optimization process. The universe is the same. Physical laws create constraints, and those constraints naturally produce paths that minimize action, not because of intention, but because of mathematics. But let's go deeper. Take quantum mechanics. In Feynman's path integral formulation, you calculate the probability of a particle going from point A to point B by summing over all possible paths. Every path contributes a probability amplitude, and you add them all up. Most paths have wildly different phases and cancel out, but near the classical path, the minimum action path, the phases align, the amplitudes add constructively. So the classical path isn't the only path the particle takes. It's just the path where quantum contributions don't cancel out. This is why large objects seem to follow definite trajectories while quantum particles do weird things. For a baseball, the quantum paths are so close to the classical path that they all interfere constructively. You see one clean trajectory. For an electron, the quantum paths spread out. You see probabilistic behavior, but the underlying principle is the same. The universe explores all paths. What you observe is what survives the interference. Let me give you another example. You drop a stone into a pond. Ripples spread outward in circles. Why circles? Because a circle is the shape that maximizes area for a given perimeter. Or equivalently, it minimizes perimeter for a given area. The water isn't doing geometry, but the physics of surface tension and energy naturally creates circles. That's optimization without intention. And that's what the principle of least action is. Now, why does any of this matter? Because it reveals something profound about the structure of reality. The laws of physics aren't arbitrary rules imposed from outside. They're expressions of symmetry, conservation, and optimization. Feynman showed that every conservation law corresponds to a symmetry. Energy is conserved because the laws of physics don't change over time. Momentum is conserved because the laws don't change from place to place. And the principle of least action ties it all together. It's the unifying thread. One principle generates all of classical mechanics, all of electromagnetism, all of general relativity, all of quantum field theory. In his lectures, Feynman called it the most beautiful and profound principle in physics. But here's the honest part. We don't know why the universe follows this principle. We just know that it does. The equations work. The predictions match experiments. But the deep why this optimization structure exists at all, remains a mystery. Maybe it's the only logically consistent way for a universe to function. Maybe there are other universes with different principles and we just happen to be in this one. Maybe the question itself is meaningless. Feynman was comfortable with that uncertainty. He said physics isn't about finding ultimate answers. It's about finding the patterns that describe what we observe. And the principle of least action is one of the deepest patterns we've found. Let's bring it back to you. Right now, as you sit there, billions of processes in your body are following the principle of least action. The neurons firing in your brain, the molecules vibrating in your cells, the electrons orbiting in every atom. All of them are taking paths that minimize action, not because they're smart, not because they calculated, but because the structure of physics naturally produces that outcome. You are an optimization process. Your body is a collection of particles following the path of least resistance through the quantum foam. And here's the beautiful part. You don't feel lazy, you feel alive. You feel like you're making choices, acting with intention, creating your own path. But underneath, at the level of atoms and forces, every particle in your body is doing the minimum necessary work to get from point A to point B. The universe isn't wasteful, it's efficient, ruthlessly efficient. Go outside, throw a ball, watch it arc. That curve isn't random. It's not arbitrary. It's the path of least action. The path that minimizes the difference between kinetic and potential energy along the way. The ball doesn't know this, but the universe does, because the universe is the biggest optimization algorithm ever written, and you're living inside it. As Feynman once reflected, nature uses only the longest threads to weave her patterns, so each small piece of her fabric reveals the organization of the entire tapestry. The principle of least action is one of those threads, and when you pull on it, the whole structure of physics starts to make sense. Not because we understand why it works, but because we see that it does, and that's enough to build a civilization on. The universe is lazy, and somehow that laziness creates everything.